In this next video one shot series, we are going to look into a very complex chapter of IIT JEE mathematics. That is nothing but complex numbers. So this is one of those chapters in your JEE mathematics where a lot of students face problems. Especially if you look into this chapter, there are two parts of the chapter. The first one that talks about algebra of complex numbers. That is one part where most of the students are generally a little bit comfortable. But then there comes the next part of the chapter, that is geometry of complex numbers, where most of the students preparing for a JEE exam usually face problem. So in order to help you out, I have divided this chapter into 13 problem types. And I am going to take problems starting from 2019 to 2023 in order to illustrate these 13 problem types and how to solve problems in each of these categories. So by watching this video, you will not just gain the insight into solving problems into complex number, you will also gain insights into what kind of problems JEE faced and made from 2019 to 2023 and what should be a strategy to solve those problems. Also, you will get an in-depth survey of PYQs from 2019 to 2023. So let us deep dive into it. Now, based on the latest syllabus of JEE provided to us, the changes between 2023 to 2024 syllabus has been just one, that is they have removed this topic triangle inequality. Now questions based on triangle inequality used to be asked in context of modulus, but now that part has been removed and you can see that the remaining part of the syllabus remains same. Also, do not get deceived by the syllabus that is given to you. Usually the extent of the theory asked in the questions is much more than the actual syllabus given by the NTA on their website. So from complex number, usually you will find 1 to 2 questions in your JEE Mains exam. Usually these questions are based on this mind map or these topics in the mind map. So if you look into this chapter, the important areas are iota and the definition of complex numbers. Then the algebra of complex numbers, how to add, subtract, multiply, divide complex numbers. The next idea is 3 important concepts regarding conjugate, modulus, argument of a complex number. Then using these 3 ideas, we come up with 3 representations in Cartesian, trigonometric and exponential form. Then we use this idea to find the roots of unity and ultimately end the chapter with geometry of complex numbers, where we discuss concept regarding points in rotation, then equation of line, equation of circle and equation of conics in complex numbers. So the first problem type is problems based on iota. Now we all know that iota is nothing but root of -1. But this alone will not help you solve the problem. So there are 2 small properties that you need to know. The first one is if I take iota raised to the power 1, it remains iota. But if I do iota square, then it becomes root of -1 whole square, nothing but -1. And again, if I multiply by one more iota, it becomes -i. And iota raised to the power 4, again if I multiply by iota, becomes minus of iota square, or minus of 1 into minus of 1 becomes 1. And if you keep doing this process, it will keep happening. That means iota raised to the power 5 will again be equal to iota. Iota raised to the power 6 will again be equal to iota square. Iota raised to the power 7 will be iota cube. And iota raised to the power 8 will be nothing, iota raised to the power 4. You can see that this process is cyclic in nature. And if you take any power of iota as 4n type, then you can see that the answer will come out to be 1. If I take 4n plus 1, it becomes iota. 4n plus 2, it becomes iota square. And 4n plus 3, it becomes iota cube. Another interesting property is if you take these 4 consecutive powers of iota and add them. So what it will become is iota plus iota square plus iota cube plus iota raised to the power 4. That is nothing but iota -1 plus minus I plus 1. And if you see that now the terms are cancelling out and the answer becomes 0. So the next property says that the sum of 4 consecutive integral powers of I will always be equal to 0. Now let us look into this question that was asked in JEE 2022. In this question, they are talking about equating 2 terms involving 1 plus I by 1 minus I. So if you take this basic idea of 1 plus I by 1 minus I, and this idea would be asked multiple times, and simplify it by multiplying by 1 plus I numerator and denominator, what you will get is in the numerator 1 plus I raised to the power 2 by 1 square minus I square. And this can be written as in the numerator 1 plus I square plus 2I. And the denominator becomes 1 plus 1 because I square is equal to -1. And hence you can see that it comes out to be 1 minus 1 plus 2i by 2. So answer becomes nothing but I. So now if you look into the question once more, what is given to us in this question is nothing but I raised to the power m by 2 is equal to I raised to the power n by 3 is equal to 1. Now if I take this first one and equate it to 1, then for this to happen, the minimum value of m by 2 should be equal to 4 because I raised to the power 4 is equal to 1. So m comes out to be 8. And for the next scenario to satisfy, n by 3 should be equal to 4. Hence, n is equal to 12. So what they're asking, what is the HCF or greatest common divisor of 8 and 12? So that is nothing but 4. So answer of this question becomes nothing but 4. The next problem type or type 2 problem is based on operations of complex number. So if I take two complex number and equate them, like x plus iy is equal to 2 plus 3i. So this can only happen when the real and imaginary parts are equal. So x is also known as a real part of z and y is also known as imaginary part of z. So in this case, it should become equal to 2 and this should become equal to 3. The next is we are talking about additions. This was the first concept. The next is addition. So if you add 2 plus 3i with 4 plus I, and if you add this complex number, the technique is very simple. You add the real part to real part and the imaginary part to imaginary part. So answer will become 6 plus 4i. The third concept talks about nothing but subtraction. So if I take 2 plus 3 and subtract 4 plus I, again the same idea, you subtract the real part from real part and imaginary part from imaginary part. So answer becomes nothing but minus 2 plus 2i. Fourth idea is nothing but regarding multiplication. So again, if I take 2 plus 3i and multiply 4 plus I, so I'm going to multiply like we multiply two polynomials. So what we are going to do is we are going to apply distribution. So if I distribute, 2 will be first multiplied to 4 plus I and then 3i would be multiplied to 4 plus I. So if I do that, it becomes nothing but 8 plus 2i and this becomes nothing but 12i plus 3i square. And we know that I square is nothing but equal to minus 1. So it becomes minus 3. And now if you add it up, what you are getting is nothing but 5 plus 14i. So this is how you multiply two complex numbers. And the last of the fifth part is nothing but division. So if I have to divide 2 plus 3i by 4 plus I, what I'm going to do is I'm going to rationalize. So I'm going to multiply by 4 minus I in the numerator and denominator. So the sign of I you can change and then multiply. And if you do that, what you are getting in the numerator is again the multiplication of two complex numbers. So we can again distribute 2 into 4 minus I plus 3i into 4 minus I. And in the denominator, you can write it as 4 square minus I square. And since we know that I square is equal to minus 1, so if you simplify it is 8 minus 4i plus 12i minus 3i square. Then denominator becomes 4 square plus 1. So the numerator, if we add everything up, it becomes nothing but 11 plus 8i and denominator it becomes nothing but 17. So your answer becomes 11 by 17 plus 8 by 17i. Now let us look into this question that came into 2019. So this is a quite simple question based on equality of complex numbers, wherein the real part and imaginary part on both the sides needs to be equal. So in order to solve this question, we are going to first take LCM. So minus 2 into 3 times minus I by 3 whole cube will be equal to x plus iy by 27. And if I simplify this, this is nothing but minus 6 minus I whole cube by 3 cube is equal to x plus iy by 27. And if you further simplify this, this becomes nothing but minus 6 whole cube plus minus I cube plus 3 times minus 6 whole square into minus I and then plus 3 times minus 6 into minus I whole square by 27, but that 27 we can cancel on both the sides, so it becomes nothing but equal to x plus I. So this is what we are getting. Now if we simplify it further, what I get on the left hand side is minus 216 minus I cube, and this will become nothing but minus 108 into I. Next term becomes nothing but minus 18 I square. This is equal to x plus iy. And now this is 216. This would become plus 18. So if I simplify, it becomes 198. This is minus I cube, so it will become plus I. This is 108i is equal to x plus iy. And if I do some very basic calculation, now you can see that it becomes minus 198 minus 107i is equal to x plus iy. So your x becomes nothing but minus 198 and y becomes nothing but minus 107. This much we are getting. Now if I subtract y minus x, it is nothing but 107 minus of that plus 198, that comes out to be 90. Now let us look into another problem that came into JEE Mains 2022. In this problem, you can see there is one part that is in the numerator, that is 1 plus 2i raised to the power 8. So I'm writing this as 1 plus 2i raised to the power 2 ka whole cube into 1 plus 2i whole square. So you can see that I have separated the 1 plus 2i raised to the power 8 into 6 plus 2, that is 8. And then if I take this another part, it is given as 1 minus 2i raised to the power 2. That is the reason I separated, because you can see that this number is getting multiplied with its conjugate. So it will become a square plus b square. So now, if I look into the denominator, it is again very interesting with 2 plus 3 plus 2i. And here if I take conjugate, 4 plus 6i. And now if I look into the numerator, 1 plus 2i whole square, it becomes 1 plus 4i square plus 4i raised to the power 3. And then if I combine the remaining two terms, it is 1 plus 4 raised to the power 2. And in denominator, you can see if I multiply, it becomes nothing but 12 plus 18i, then 8i minus 12. After doing this simplification, this becomes quite simple, because in numerator what we are getting is minus 3 plus 4i whole cube. And then this will become 25, 1 plus 4 whole square. And denominator, this 12 and 12 gets cancelled out and it becomes 26i. If I expand the cube, a plus b whole cube given in the numerator, it becomes nothing but a cube plus b cube plus 3a square b and plus 3ab square. Okay. And now this is quite simple to interpret, because all the terms here, we know what they mean and what they are equal to. But we will also have 25 by 26i along with it in multiplication. Now if I look into this, this is not very tough. What I can do is I can simplify. The first part becomes nothing but minus 27. The next becomes nothing but 4 into 4, 16, 64i. And then next is nothing but 9 into 3. So it is nothing but 12 into 9, that is 108i. And the next part becomes nothing but plus 3 into 3 into 4 square, that is nothing but 144. And along with that, we have again that 25 by 26i. Now, if you simplify this part, what we are going to get, this I is not in numerator but denominator, sorry. So once I simplify this, only I need to simplify this part, because here we have an I, this I will get cancelled out and we will get the real part as answer. Okay, if you want to simplify, you can simplify the whole, but I'm telling you what is going to happen. So if I just simplify this part, what we are getting is nothing but 44. So this would be something plus 44i. Now I'm not worried about this x, and this you can also adapt as a problem solving technique. Worry about the calculation of the relevant part, because what we want is a real part, and that will get from here. And if you simplify this, it comes out to be 550 by 30. So D option is correct. Now let us look into this next question. And what we can do is we can put the value of z as nothing but x plus 10i, because they have given the imaginary part of z as 10. So once I do that, what is going to happen is nothing but 2 times x plus 10i minus n by twice of x plus 10i plus n will be equal to 2i minus 1. And now, if I do a little bit intelligent thing and take this 1 on the other side, so this will become 2x plus 20i minus n by 2x plus 20i plus n plus 1 is equal to 2i, and our calculation will become simplified because of this. Now if I take LCM here, it is 2x plus 20i minus n plus 2x plus 20i plus n divided by 2x plus 20i plus n is equal to 2i. You can see that the n gets cancelled out. Once you have done that, we can move further. And now if I add the numerator up, what I am getting is nothing but 4x plus 40i. If I multiply the denominator on the right hand side, it is 2i into twice of x 20i plus n. 2 we can cancel on both the sides. This becomes 2x plus 20i is nothing but 2x plus n into I, and then plus 20i square. If I simplify this, what I'm getting is twice of x plus 20i. This is equal to nothing but minus of 20 plus 2x plus n So you can see that the value of 2x comes out to be equal to minus 20, and therefore x becomes nothing but minus 10. So all the options giving us is the real part of z as minus 10 will become correct. So now you can see that either A or C can be the correct option. In order to find which one is further correct, we can compare the imaginary part, and if I do so, what we will get is 20 is equal to twice of x plus n. So 20 is equal to 2 into x, that was minus 10 plus n. So n becomes nothing but 40. So you can see from here our option C becomes correct. N is equal to 40 and x is equal to minus 10. Now let us look into next question that was asked in JEE 2021. In this question, if I put the value of z as nothing but x plus iy, what I will get on my left hand side is x plus iy plus alpha times mod of x plus iy minus 1 plus 2i equal to 0. Now if I do this, what am I going to get is, if I separate the real part, it is going to be alpha. This x plus iy minus 1 can be written as mod of x minus 1 plus iy, and since it is a modulus, it is going to be a real value. So this is our real part, plus y plus 2 into I. This is going to be imaginary part. So now, since it is equal to 0, we'll equate both the parts to 0. If I equate my imaginary part to 0, x plus 2 becomes 0, and that implies y is equal to minus 2. And further, for solving this, we'll put the real part also as 0. So x plus alpha times, I can interpret this modulus as root of x minus 1 whole square plus y square. This is equal to 0. If you further solve this, this can be written as x plus alpha times root of x minus 1 whole square, and since y is equal to minus 2, y square becomes 4 equal to 0. Now in order to find the greatest and least value of alpha, what I can do here is, I can do some minor calculations. So I can take minus alpha root of x minus 1 whole square plus 4 on the right hand side and square both the sides. So this becomes x square alpha square, and inside this becomes x square minus 2 plus 5. If I simplify this, what I'm getting on the right hand side is alpha square minus 1 into x square minus 2 alpha square x and 5 alpha square equal to 0. Now once I've got this, this is the quadratic equation in x, and this equation is going to have real root only when the d or discriminant of this is greater than or equal to 0. If I apply this property, then b square minus 4ac, so here b is nothing but 2 alpha square minus 4a, that is alpha square minus 1, and c, that is 5 alpha square, should be greater than or equal to 0. Now if I simplify this part, I can take this 4 alpha square as common, and if I do so, what I'm left with is alpha square in the first term. In the next term, it will become nothing but 5 times alpha square minus 1 is greater than or equal to 0. And if I further simplify it, now this 4 alpha square will have no consequence. If I simplify the remaining part, it is minus 4 alpha square plus 5 is greater than or equal to 0. Or we can write this as alpha square minus 5 by 4 is smaller than or equal to 0. Sign has changed because we have multiplied by negative quantity on both the sides of inequality. So you can see that the value of alpha will belong to root 5 by 2 minus root 5 by 2 to root 5 by 2 in this duration. And once you have this, you have got the value of p and q. Your p is nothing but the least value to minus root 5 by 2, and q is nothing but root 5 by 2. What they're asking is p square plus q square into 4. If you put in these values, this becomes 4 times 5 by 4 plus 5 by 4, that comes out to be 10. Now let us move to the next problem type. This next problem type is the one that is based on properties of conjugate. Now let us first look into what are the properties, what is the conjugate, what are the properties of conjugate, and then let us move into the problems that were based in JEE based on this idea. So conjugate is a very simple idea. If we have 2 plus 3i, a conjugate will be represented by a bar, and that would mean 2 minus 3i. In terms of geometry, this means a reflection over the real axis. Now if you look into the properties, if I do conjugate one more time, so we already had this value. If I do take conjugate one more time, you can see that I will get my original number, that is 2 plus 3i, and this is my first property. Second property talks about, and this is a very important idea, that if I add this number to its conjugate, so this imaginary part will get cancelled out and you will get 2 times the real part. And this is very important because sometimes the question will talk about purely imaginary numbers. So when we talk about purely imaginary numbers, then in those kind of numbers, the real part will become 0. So this z plus z bar equal to 0 will become the condition for z to be purely imaginary. And this is very important. A lot of JEE questions are based on this idea. Similarly, in the next one, what we are doing is we are taking 2 plus 3i and subtracting from this 2 minus 3i. Now you can see the real part will get cancelled out and we will get twice the imaginary part. And that is the reason that z minus z bar will be equal to 2 times imaginary part. And if I put z minus z bar equal to 0, that would mean imaginary part will become 0 and hence it becomes the condition for purely real. So these two conditions, something becoming purely real and purely imaginary, are very important conditions from JEE Mains point of view. Now, what we are doing next is we are talking about distribution of conjugate. So if I have addition, then also it gets distributed, subtraction, again distribution, multiplication, distribution, division, distribution. So you can distribute in practically all the scenarios. Also, if we have some raised to the power n, then also we can move it inside and outside. There is no problem. And rest of the properties are fine. But there are two important ideas I will try to once more illustrate. One is this z bar. So if I take z and multiply by z bar, I will take an example. So if I take 2 plus 3i and multiply by 2 minus 3i, so what will happen? This will become 2 square minus 3i square. So 2 square plus 3 square. And this is nothing but 4 plus 9, 13. So what is happening here is if I multiply this, what I ultimately get is x square plus y square, and that is nothing but mod of z whole square. Now this is a very important property. It is not just a property, it is a root that we are going to take to maneuver through complex numbers, because we will see that there will be very less properties in terms of modulus, but in terms of conjugate we have got a lot of choices in distribution, so that we are going to utilize in solving problems. Now this problem was asked in JEE 2022. This specifically targets on the idea of z plus z bar. You can see that what we have given, this first term is z and then the z bar is given. We've already learned this property that if we have z plus z bar, it is nothing but 2 times real part of z. So this idea we need to use. Now here z is nothing but z raised to the power 5. So that does not matter. We just need to get the value of z raised to the power 5. So if I do z raised to the power 5, it is nothing but 2 plus 3i raised to the power 5. So whatever real part will get out of this, double of that would be our answer. So now let us look into this. So if I expand it using binomial expansion, what we will get is 5c0 2 raised to the power 5. Next term is 5c1 2 raised to the power 4 into 3i. Next term would be 5c2 2 raised to the power 3 3i whole square. Next term will become 5c3 2 raised to the power 2 and 3i raised to the power 3. The next would become 5c4 2 raised to the power 1 and 3i raised to the power 4 and 5c5 into 3i raised to the power 5. Now once you have this, you can just focus on those parts in this question which are real in nature. So this will be real, this would be real, and then this would be real, and the rest of them will contribute to the imaginary part. So if I look into the real part of z raised to the power 5, and it is nothing but 5c0 into 2 raised to the power 5. This I square we can put as minus sign. So 5c2 into 2 cube into 3 square. And the last part, that is nothing but 5c4 into 2 into 3 raised to the power 4. Okay, so this is what we have got so far. Now all we need to do is calculate this value and double it to get to the answer. So if I simplify the first part, it comes out to be 32. The next part would be nothing but 5 factorial by 3 factorial into 2 factorial. This 2 raised to the power 3 becomes 8, 3 square becomes 9. And this last part becomes 5c4 becomes 5 into 2 and 3 raised to the power 4 becomes 81. So this is 32 minus this will become 10 into 72. This would become again 10 into 81. So if we simplify this, what we get is nothing but 32 minus nothing but 720 plus 810, and this is nothing but 32 minus 90 and 32 plus 90, and this becomes nothing but 122. And what we want is 2 times the real part of z raised to the power 5, and that becomes nothing but 240. Now let us look into this next problem that was asked in JEE Main 2023. And in this problem you can see that again they are targeting the same that I have emphasized while telling you the properties, that purely imaginary and purely real part. So what they're saying is this is purely imaginary. This would mean that if I do z plus z bar, it should be equal to 0. So we can use this idea. So if I take 1 plus 2i sine theta by 1 minus I sine theta, and if I add it with its bar, so 1 plus 2i sine theta by 1 minus I sine theta whole bar, this will be equal to 0. And if I simplify this, it is 1 plus 2i sine theta by 1 minus I sine theta, and this will become 1 minus 2i sine theta by 1 plus I sine theta. This will be equal to 0. And if I cross multiply, what I get is 1 plus 2i sine theta into 1 plus I sine theta plus 1 minus 2i sine theta into 1 minus I sine theta equal to 0. Now what I need to just do is simplify this. If I simplify this, what I get from the first part is nothing but 1 plus 3i sine theta minus 2 sine square theta, if I simplify the first part. And from the second part, if I do it, what I get is 1 minus 3i sine theta minus 2 sine square theta equal to 0. So if I'm simplifying both of these, this 3i sine theta will get cancelled out. And what we are getting ultimately is nothing but this expression that 1 minus 2 sine square theta, 2 times of this would be equal to 0. Or my sine square theta comes out to be equal to 1 by 2. That would mean sine theta can take 2 values. And either it can be equal to plus 1 by root 2, or it can be equal to nothing but minus 1 by root 2. If it takes the first value, that is plus 1 by root 2, in 0 to 2 pi, such possible values are pi by 4 and 3 pi by 4. So these are the principal values. Similarly, for the second one, if I find the values, it comes out to be 5 pi by 4 and 7 pi by 4. What they're saying is, what is the sum of all of these values? If you add it up, it comes out to be equal to 4 pi. Hence, our answer D is correct. Now, this question can be done using one more technique. So instead of using z plus z bar equal to 0, what we could do is we can express this given complex number into x plus iy form. And since it is purely imaginary, then put the value of x equal to 0. Now, this is a valid way of doing this question. So I'm going to also show you this technique. So what you can do is you can take this 1 plus 2y sine theta and 1 by 1 minus I sine theta and multiply with its conjugate. So 1 plus I sine theta. So this is what we do in division. The same technique that I told you for division, we are using it. If I simplify it, in the numerator, it will become 1 plus 3i sine theta minus 2 sine square theta. In the denominator, what we get is 1 plus sine square theta. Now we can see that the real part comes out to be 1 minus 2 sine square theta by 1 plus sine square theta. And the imaginary part becomes 3i sine theta by 1 plus sine square theta. You can see that since it is purely imaginary, the real part will be equal to 0. So this part should be equal to 0. So what we are getting is 1 minus 2 sine square theta by 1 plus sine square theta equal to 0. Now see, there is a word of caution here. Sometimes we'll directly write this as 1 minus 2 sine square theta equal to 0. And then we'll go and find the solutions. But also check that the denominator is not getting 0 for those solutions. Okay. So sometimes we will have to avoid those solutions for which the denominator will become 0. So after this, if I solve, the solution remains same. This becomes 1 by 2. So sine theta can have two possible values, 1 by root 2 and minus 1 by root 2. Corresponding to the first one, the answers are pi by 4 and 3 pi by 4. And corresponding to the second one, the answers are nothing but 5 pi by 4 and 7 pi by 4. If you add them, the answer still remains 4 pi. Now this next question is exactly like the previous question. Just it is on steroids. So it is the same question, but we have to do the same process twice. Let us see. So if I take my first complex number, they are saying that it is purely imaginary. So now, since I have already shown you using two methods how this question can be done, what you can easily identify is the second method is shorter method. So if I multiply and divide by its conjugate, that is 1 minus 2i sine alpha and 1 minus 2i sine alpha. What I get for the first complex number in the numerator is 1 minus 3i sine alpha plus minus 2 sine square alpha. And in the denominator, I'm going to get 1 plus 4 sine square alpha. So if I split it into real and imaginary parts, you can see that the real part is nothing but 1 minus 2 sine square alpha by 1 plus 4 sine square alpha. And then there is some real part that is minus 3 sine alpha by 1 plus 4 sine square alpha. Now what they're telling us is this number is purely imaginary. That means this part needs to be 0. If this part becomes 0, then 1 minus 2 sine square alpha should be 0. That means sine alpha needs to be plus minus 1 by root 2. Now they are telling us that this alpha is there between pi to 2 pi. So plus 1 by root 2 value is not possible. Instead of this, the value that we need to consider is minus 1 by root 2. Corresponding to it, the values are nothing but 5 pi by 4. This is one of the value of alpha, and another value will be 7 pi by 4. Okay, so this process we have done in order to find the value of alpha. Now we have to do the same process one more time for beta. So let us look into that part of the process. So we will do the same thing, 1 plus I cos beta upon 1 minus 2I cos beta. Again, we can multiply by the conjugate. So 1 plus 2I cos beta and 1 plus 2I cos beta. If we multiply and divide by the same quantity, what we are going to get here is nothing but, in the numerator we get 1 plus 3I cos beta minus 2 cos square beta. And in the denominator we have 1 plus cos square beta. So you can see that the real part comes out to be 1 minus 2 cos square beta by 1 plus 4 cos square beta, and the imaginary part comes out to be 3I cos beta by 1 plus 4 cos square beta. Now once you have written this, the important thing that we need to notice here is it is purely real. That means the imaginary part is 0. So this time this part will become 0. So if I put that equal to 0, the value of cos beta becomes 0. And from here the value of beta between pi and 2 pi is nothing but 3 pi by 2. So before writing these values, we need to very carefully observe what is happening here. They are asking us values of alpha and beta between pi and 2 pi. So general values we do not need to consider. So from here, now let us go back to the question. Now this is not the question. Our question is slightly different. What they're asking in the question is all such complex numbers which are of this form. So now let us find the value of z alpha beta. So in one place, the alpha can be equal to 5 pi by 4. And beta has only one value 3 pi by 2. So one value of z alpha beta would become nothing but sine of 5 pi by 4 into 2 plus I times cos of 2 times 3 pi by 2. And if you simplify this, this is sine 5 pi by 2, that becomes 1. And that is cos 3 pi, that becomes minus. This you can simplify. Similarly, there is one more value that we need to find. And now this value will come when alpha becomes 7 pi by 4. And beta has only one value, that is 3 pi by 2. So if I find z alpha beta corresponding to this value, it is sine of 2 times 7 pi by 4 plus I times cos of 2 times 3 pi by 2. So again, if you simplify this value, what you get is minus 1 minus I. So we have got both the values. Now all we need to do is find this summation. And this is not very difficult to find. Let us find this summation. So in the final step, before finding summation, if you can simplify this quantity that is given to us. So let me write this quantity first. What we are given is z alpha beta plus 1 by I times z alpha beta bar. If I just take LCM, this would become I square z alpha beta z bar alpha beta plus 1. And denominator it is nothing but I z bar alpha beta. If I multiply by z alpha beta, something very interesting comes. And that is nothing, in the numerator what we have is 1 minus mod of z alpha beta whole square. And in the denominator we have I times mod of z alpha beta whole square. And in multiplication what we have z alpha beta. We need to find the summation of all such values. So you can see that one value of z alpha beta was nothing but my plus 1 minus I. And another one minus 1 minus I. If I put both of these values and simplify, so my answer or summation now will come out to be, and if I put these values, so let us put the first value 1 plus 1 minus I. If I put in the numerator, mod of this becomes divide by nothing but I into 2, and this value comes out to be 1 minus I. For the second one, if I calculate, it becomes 1 minus 2 by I into 2 into minus 1 minus I. If you simplify this comes out to be 1. Hence option C. So you can see that this question had 3 important parts. First, what we did in the earlier question, that we had to do purely imaginary, then purely real, second part. Then in third part, we had to find the value of alpha beta, z alpha beta. Those two values we got. And in the fourth part of the question, we had to find the summation that was given in the question. This was a very interesting question having 3 different parts, hence a little bit lengthy also. Now, again, this is a very interesting question asked in 2020. Question says that this equation has 2 roots, which are conjugate complex numbers. So if I assume one to be z, another one would become z bar. Now they are saying that both of these satisfy this equation, so find the relationship between the. Very interesting question. So now what we can do is we can use this idea that zz bar is equal to mod of z whole square. This core property that we learned, we are going to use it in some form, not exactly like this, but some form. So now let us start with it. So now if these two roots are there for this equation, then we can write the sum of roots as minus b by a and the product of root as nothing but c by a. So these two ideas we have got. Next thing what they are saying is they satisfy this equation. So now modulus we cannot modify, but if I square both the sides, it will become 4 into 10. And this part I can write as z into z bar is equal to 40. Now if I simplify this, this is z plus 1 into z bar plus 1 is equal to 40. And if I multiply this, it is z bar plus z bar plus 1 is equal to 40. Now we can put values here. So you can see that this value was nothing but minus b. So if I put here, it becomes nothing but this value becomes minus b plus 1. And the earlier one would become nothing but 45. So from here you can see that what we have is 46 minus b on the left hand side and 40 on the right hand side. So b clearly is equal to 6. Once we have found this value, now we need to satisfy the options and check which of the options is getting satisfied. So now if you take your option B and check, it is nothing but 6 square or b square minus b, to 6 square minus 6 would be nothing but 36 minus 6 comes out to be 30. You can see that your B option is getting satisfied. Simple but an elegant question. Now next problem type is nothing but based on properties of argument. Let us quickly go into the properties of argument, then see what kind of questions are framed on it. So now first, what is argument? So argument is nothing but tan inverse y by x. Now there are two types of argument. One of it is known as principal argument. So when we say principal argument, it would mean the value of the argument should lie between minus pi to pi, where minus pi is open and pi is closed. When we talk about general argument, it can be any value that lies between real numbers. Now, if I have to find the value of principal argument, the logic is that there are three steps. First, you determine the quadrant, in which quadrant the complex number lies. Second, find the value of theta, that is nothing but tan inverse mod of pi by x. And in the third step, based on the quadrant, you give the value of argument. So let us say that if it is in the first argument, then the answer would be theta. Second quadrant answer will be pi minus theta. Third one, minus pi plus theta, and 4 minus theta. So whatever value we are getting in third and fourth are nothing but negative value of the quadrant just above it. So if we have this, based on that, you can quickly give the answer. Let me take an example. So if I have to find the value of minus 1 minus I, the first thing that we are going to notice is what is the value of theta? That is nothing but tan inverse of mod of pi by x. So that becomes minus 1 by minus 1. So this becomes pi by 4. Now, once you have observed this, you have also observed the quadrant. So it is nothing. Since x is negative, y is negative, it is in the third quadrant. So our answer of argument of z would be nothing but the third quadrant, that is minus pi plus theta. So minus pi plus pi by 4, that is nothing but minus 3 pi by 4. So this is how we find it. The properties of complex numbers are not very difficult to remember. If you are multiplying two complex numbers, then their argument will get added up. If you are dividing two, it gets subtracted out. And if you are raising some power, then it gets multiplied into the complex numbers. So you can see that these are exactly like properties of log. So nothing very complex to remember. Just apply the properties of log and you will get the answer. Now, if you are applying the property in terms of general argument, then one more thing will come, that is this 2k pi. And this question has been directly asked in JEE advanced exam one time. So it is a good idea to remember this basic idea. Now, apart from this, if you remember one more small thing, then your life will become even more simpler. So let us say that your complex number lies in first quadrant. So this is z. So what we are saying is, if the argument in the first quadrant is nothing but theta, and if I take z bar, so it goes in this quadrant. So if this angle was nothing but theta, then obviously this angle would become minus theta. And if I take minus of z, then it will go here. So not minus z bar, minus z, it will go here. So now based on that, you can again understand what will be the answer in this case. And if you take minus of z bar, then it goes in the second quadrant. So again, you can understand what is going to be the answer. So it is very simple if you look into this manner. But if you want to apply the properties also, from there also you can get the answer. So let us jump into the first question. And you can very easily solve this question by properties of log. So this part you can easily write as argument of minus 1 into z minus argument of z. And now very easily you can apply the property, and multiplication of two complex numbers argument can be written as addition, exactly like we apply the property of log. This will get cancelled out, and what we are getting is argument of minus 1. If you can draw a very small diagram, you can observe that minus 1 lies here. So this angle is nothing but pi. So your answer becomes nothing but pi. Now let us look into this very simple next question that came into 2023. In this question, they have given the value of z and z word in terms of z. So if I simplify z1, what I will get is, if I take LCM in the denominator, it becomes 1 plus I z bar into z by zz bar into 1 minus z plus 1. And if I open this bracket, this is z plus I zz bar by nothing but this will become mod of z whole square into 1 minus z plus 1. Now let us put the value. So it becomes 1 plus I in place of z. This becomes square. So mod of z is nothing but root 2. The mod of z whole square will become 2. This also becomes 2. This is 1 minus I plus 1. And if you do this very simple calculation, in the numerator what you are getting is 1 plus 3i. In the denominator what you are getting is 1 minus 2i after simplification. So if I rationalize by multiplying 1 plus 2i and 1 plus 2i numerator and denominator, what we get is nothing but 1 plus 5i minus 6 and denominator again 5. So your answer becomes nothing but minus 5 plus 5i by 5. It is nothing but minus 1 plus I. And if you take the argument of z1, it comes out to be nothing but 3 pi by 4. And if I multiply this by 12 by pi and find 12 by pi into argument of z1, it comes out to be nothing but 12 by pi into 3 pi by 4. And that would be nothing but equal to 9. Now let us look into this very simple and elegant question that came in JEE 2022. In this question, a relationship between z1 bar and z2 bar is given. And in fact, two relations are given and we have to comment on the argument of z1 and z2. So now if I take argument on this first statement, we can write argument of z1 bar as nothing but argument of I z2 bar. And using the properties, I can write this is argument of I plus argument of z2 bar. So it becomes argument of z1 bar. Argument of I becomes pi by 2 and then argument of z2 bar. This is my first equation. Another relation that they have given here also, if I apply the properties of argument like log, argument of z1 minus argument of z2 is nothing but pi. This is my second expression. And also if I do a little bit of manipulation and before writing this equation, I can take this pi, I can take this argument of z2 on the other side. In fact, it is z2 bar, not z2. And it becomes pi plus argument of z2 bar. This is my second equation. Now what you can do is you can subtract from second equation first equation. If you do that, what you get on the right hand side is argument of z1 minus argument of z1 bar, and this would be equal to nothing but pi by 2. Now we knew that if argument of z1 is here, the bar would be here. So if this angle is theta, this is also theta. So if the argument of this is theta, then this will become nothing but minus theta. So what we can write is if this is theta, this becomes minus theta. And this is pi by 2, twice of theta becomes pi by 2 or theta becomes pi by 4. So what we can say is argument of z1 or theta is nothing but pi by 4, that is option C. Now let us start this next question that was asked in 2021. So again the question is very simple. They have given the value of omega. And they are again talking about another complex number z. And a relation between their arguments is also given. So now if I find the argument of w, it would be nothing but minus of pi by 3. And we have talked about this multiple times. I can just observe and find. If you want to find, there was a method that we earlier discussed. If we want to find its modulus, it would be nothing but 2. And now simply what is given is relation between argument of z and w is given. So if I take argument of w on the other side, it is pi by 2 plus argument of w. And since this is nothing but minus pi by 3, argument of z becomes pi by 6. Also, there is a relationship between argument of w and z that their multiplication is equal to 1. So from here, if I want to find argument of z, it is nothing but 1 by argument of w. That is nothing but 1 by 2. So from this, we have two informations. One is that argument of w is equal to pi by minus pi by 3. This is one very important logic or information. And another one is, we talk about z, the modulus of z is nothing but 1 by 2 and argument of z is nothing but pi by 6. Now they are talking after this information about a triangle that is that if I draw an Argand plane, this is how it looks like. So one point is origin and then another point is z. So if I draw z, it is going to be somewhere like this. The distance from origin is 1/2, this angle is 5/6. And if I talk about w, it is nothing but in the fourth quadrant, where this distance is 2 and this distance is nothing but, this angle is nothing but pi/3. And now they're talking about this triangle OAB. Let us say this is O, this is A, this is B, and want to find the area of this. Now there's a very simple formula that area of triangle is nothing but half of multiplication of two sides and sine of angle between them. So if I apply this formula, OA is 1/2, OB is 2, and sine of angle between them is nothing but pi/2. So if I do this, the answer becomes 1/2, and that is nothing but option 2. Now this next question is a very simple question asked in 2020. Looks like a complex question, but once you write it down, it is very simple. So if I take this z1 as a complex number x1 plus iy1, and if I consider z2 as a complex number x2 plus iy2. So now what this question is saying is, if you find real part of z1, that is nothing but x1, it would be equal to mod of z1 minus 1. So if I write it, is it x1 plus iy1 minus 1. So if I write x1, it is nothing but root of x1 minus 1 whole square plus y1 square. And if I square it, it becomes x1 square is equal to x1 minus 1 whole square plus y1 square. And if you simplify, this is x1 square, this becomes x1 square minus 2x1 plus 1 plus y1 square. x1 square cancels out. What we'll get is 2x1 minus 1 equal to y1 square. Now, if you look into second relation, it is exactly same relation. So if I simplify that also, instead of x2, x1 I will have to write x2, and instead of y1 I will have to write y2. So these are the two equations that I'm getting. This is first part of the problem. Now what they're saying is they've also given us argument of z1 minus z2. Now also let us also write this, what is z1 minus z2. So if I subtract z1 and z2, it is going to be a complex number x1 minus x2 plus I times y1 minus y2. So when they're talking about its argument, that would mean tan inverse of y1 minus y2 by x1 minus x2 would be equal to nothing but pi/6. Or in other words, y1 minus y2 by x1 minus x2 is equal to tan of pi/6, that is nothing but 1/√3. This becomes my second important relation. This is second important idea. Now, what we can observe here is what they're asking is imaginary part of z1 plus z2. Now, what is z1 plus z2? So if I add z1 and z2, it is x1 plus x2 plus I times y1 plus y2. So this is nothing but the value of y1 plus y2. So for finding that, now we can use a very simple technique using this equation. So if I subtract from equation 1, equation 2, what I'm going to get is 2 times x1 minus x2 is nothing but y1 square minus y2 square. That if I simplify, can be written as 2 times x1 minus x2 is equal to y1 minus y2 into y1 plus y2. Now, if you look into this, the ratio of y1 plus y2 by x1 plus x2 we already know. So if I simplify this expression in this terms, 2 times x1 minus x2 by y1 minus y2, I will be able to get the value of y1 plus y2 that is asked in the question. Now this is simple to get by, because this ratio I already know. If I put the value, this is 1 by √3, but that is nothing but 2√3. So my option comes out to be D. Now let us move to our next problem type, that is properties of modulus. In this, first we are going to look into the properties of modulus and then what kind of problems are based on that. So if you look into the idea of modulus, it is nothing but mod of z is nothing but root of x square plus y square, and technically it is the distance of a point from origin. Okay, so this is a very important idea. Geometrically you should have imagination what does modulus of z means. Now since it is root of x square plus y square, it is obvious to say that mod of z is greater than equal to x and mod of z will always be greater than equal to y. So these are basic things, and obviously since it is distance from origin, if I put a bar also the distance is not going to change, and if I put a minus sign also it is not going to change, and if I put both bar and negative sign still it is not going to change. So from here you can get some very simple properties, and if you look into the core concept of distance from origin. Now if I look into the properties, one basic idea is obviously if it is distance it needs to be greater than equal to 0. If we say mod of z is equal to 0, this would mean that real part and imaginary part of z are both 0 because the complex number itself has become 0. If I am saying modulus of z is greater than 0, this would mean that z cannot be equal to 0 because it has some distance from origin, so it cannot be equal to 0. Next is your real part of z, that is nothing but x will lie between mod of z and z. Next important property is, this we have already done when we did conjugate, that zz bar is equal to mod of z whole square, and this is very important rule to take mod into the realm of conjugate, and from there apply the properties of conjugate and simplify it. Now you can see that if I talk about distribution of modulus, it works on multiplication and division, but not on addition. So if I have z1 plus z2 mod, then in order to interpret this, I will have to use my resultant formula. That is nothing but root of, and you might have seen this in vectors, z1 square, z2 square plus 2 times z1 mod, z2 mod, and cos of angle between them. This is a very important idea. Now, this can also be turned into an inequality that is known as triangle inequality. But now, JEE has categorically removed it out of the syllabus. So I have also removed it from my teaching notes. I am not going to cover triangle inequality because it is categorically out of your JEE mains syllabus. Also, you do not need to cover it for JEE mains point of view. For JEE advanced, you can cover it. Now let us look into this 2019 question. It is again a very simple question based on very simple properties. What they are saying is a complex number z is given and its magnitude is also given. Then they are finding the value. They want us to find the value of nothing but z bar. So interestingly, if the modulus is given and if I apply the condition based on my properties that I have learned, my modulus is going to be distributed in numerator and denominator. And since it is power, based on this property that mod of z raised to the power n is equal to mod of z raised to the power n, this square can be taken outside the mod sign. And in denominator also, it is 1 minus I mod. If I apply it in the numerator, it will become nothing but root 2 whole square. In the denominator, it becomes root of a square plus 1. Now, given this value is nothing but root of 2 by 5. If I simplify it and if I square both the sides, what I'm going to get is nothing but, this was 2. Again, if I square 2 square, this will become nothing but 2. The mod will get removed. Here it will become 5. And here in the denominator, it becomes a square plus 1. And if I simply simplify it, the value of a square plus 1 comes out to be 10. And hence a comes out to be equal to plus minus 3. Now these are the values that I'm getting. Now they have clearly given in the question that a is greater than 0. And from here, we do not need to consider the negative value of a, that is minus 3. So a becomes nothing but plus 3. Now once I've got this value, now from getting this value, I can write the value of z as nothing but 1 plus I whole square by a minus I. So this came out to be 3 minus I. And numerator, if you simplify it, is 1 plus I square plus 2i. And I square is minus 1. So this part becomes 0. And this is 3 minus I. So the value of z is nothing but 2i by 3 minus I. And here, if I take bar, that is what they want us to, it becomes minus 2i by 3 plus I. In order to divide it, I will multiply by 3 minus I in numerator and denominator. And if I do so, what I get in the numerator is minus 6i plus 2i square. And in denominator, what we get is 3 square plus 1. And if I further simplify it, it becomes nothing but minus 2 minus 6i by 10. And this becomes minus 1 by 5 minus 3 by 5i. Now let us see which option matches. So you can see that your option B is getting matched up. And hence it becomes our answer. Now let us look into another question that came into 2021. And now this question, if you see, it is a combination of log and mod, primarily a question of mod only. So if I interpret this using properties of mod, you can see that the property of mod says that if you have log of x to a base that is between 0 and 1, and if you have to interpret this, so what will happen is we'll write x here, this sign will get flipped because this number is between 0 and 1. And this 1 by root 2 raised to the power 2 will come. Same logic we are using here. This sign will get flipped. It is 1 by root 2 raised to the power 2. So this becomes mod of z plus 11 by mod of z ka whole square minus 2 times mod of z plus 1. And this becomes greater than 1 by 2. If I take 2 on the other side, 2 times mod of z plus 22 is greater than equal to mod of z whole square minus 2 times mod of z plus 1. And if I simplify it, it becomes nothing but mod of z whole square minus 4 times mod of z minus 21 is smaller than or equal to 0. If I simplify this, this comes out to be, after factorization, mod of z minus 7, mod of z plus 3 is smaller than or equal to 0. Now, if you look into this second part, this is always positive because sum of two positive quantities. So mod of z minus 7 is going to decide the sign. So mod of z, you can see, is smaller than equal to 7. So the largest value, or the largest value comes out to be 7. That is nothing but option 2. So primarily a question of log and some logic and some basic properties of modulus getting used. Now this very simple question came in 2022. This is primarily based on a very simple property of modulus. We'll see. So here what they're saying is this equation has two roots, alpha and beta. So if I put alpha square should be equal to 1 minus 2i. And if I put beta, again beta square will be equal to 1 minus 2i. So I have kept this on one side and taken this on the other side. That's it. Nothing complicated I have done. So if I get these two alpha square, beta square value, I can put it here. So this will become 1 minus 2i raised to the power 4. Second term will also become 1 minus 2i raised to the power 4 modulus. So it is mod of 2 times 1 minus 2i raised to the power 4. 2 I can take outside based on properties of mod. And we know that the very simple property z raised to the power n mod is equal to nothing but mod of z raised to the power n. This very simple property can be used here. So what I can do is I can take this 1 minus 2i inside and 4 outside. So this becomes nothing but root 5 raised to the power 4. That is nothing but 2 into 25. That is nothing but 50. So option A becomes correct. Now let us look into this next question. Now these kind of questions have been asked in JEE. Now this 2022 question talks about a V, that is sum of 3 mods. So if I try and put the value of z is nothing but x plus I and open this first mod, then this becomes x square plus y square. The next one would become x minus 3 whole square plus y square. And the next one would become x square plus y minus 6 whole square. If I simplify this, this becomes x 3 times x square 3 times y square, then there would be minus 6x, then there is going to be minus 12y, 1 3 square, that is 9, and 136. If I simplify this, this is 3x square plus 3y square minus 6x minus 12y plus 45. Now what I can do is I can take these terms of x's and take 3 common, so this becomes x square minus 2x, then take this y wala terms and take again 3 common, so y square minus 4y, and then you can see a 45 is left. Now I can make a perfect square out of both of them, and if I do so, it becomes x minus 1 whole square minus 3. This becomes y minus 2 whole square minus 12 plus 45. What you are getting is x minus 1 whole square into 3 plus 3 times y minus 2 whole square, and then 10. What they're talking about is what is the minimum value of v. You can see that this perfect square we have formed not to get the minimum value only. So this becomes 0, this becomes 0. The minimum value is going to be 30. So from here we get the value of x, that is nothing but equal to 1. The value of y, that is nothing but equal to 2. And the value of v naught, that will be equal to 30. Corresponding to this, the z comes out to be 1 plus 2y. Now this is very important because the next part of this question is and it's based on this only. Now we have to put these values, simplify and get the value of the last term that they're talking about. So you can see that there are multiple ingredients into it. First one is z naught square. So if I take 1 plus 2i and do a square, this will become 1 minus 4 plus 4i, that is minus 3 plus 4i. This is the first part. Another part is z naught bar and then cube. So if I put bar, it is 1 minus 2i then whole cube. Now if I apply a formula a cube then plus b cube plus 3a square b plus 3a and b square. If I have to again simplify this, so this will become 1 and minus 8i cube minus 6i and then finally 12i square. And if I again simplify this, what you can see is basically we are getting plus 8i. So this becomes nothing but minus 11 plus 2i. The expression that was given to us was nothing but 2 times z naught square. So z naught square we have already figured out as minus 3 plus 4i. So if I multiply by 2, it becomes minus 6 plus 8i. Then it talks about minus z naught bar cube. So that is minus 11 plus 2i. And then finally up 3 added, then square of this plus v naught square, that is 30 square. If I simplify this, what you're getting inside mod is nothing but, after simplification, it will become nothing but 11 minus 6 plus 3, that would become nothing but 8, and then plus 6i, okay, mod ka whole square plus 900, and that comes out to be 1000. And that matches our option A. You can see that the question had two parts. One is this perfect square generation and getting the minimum value of V, that is V naught. And then after that, it is all calculation, do the calculation, get the answer. Now let us look into this 2020 question. It is a very simple question. If you plot it on a eigenplane. So let us consider Z as in the first quadrant and X plus IY. So an eigenplane, if I convert this question into coordinate geometry. So see, this one phenomena you should always understand, and it's a very useful thing, that what we are writing as 1 plus 2i on eigenplane is equivalent to writing 1 comma 2 on a coordinate plane, and is equivalent to writing I cap plus 2j cap in terms of vectors. Now this interconnection between the idea of complex numbers, coordinate geometry and vectors is very important, because time and time again we'll use this logic to solve questions very fast. Like in this case, if I consider this as z or x comma y, then this will become x comma minus y, because z bar is nothing but x minus iy. So using this basic logic to solve the question is very important. So what they are doing is, now in order to get another point, we are subtracting 2 times real part of z. So this will become a complex number x plus iy minus 2 times x. You can see that it is minus x plus 2 iy plus iy. So this point becomes minus x comma y. Similarly, this will become minus x comma minus y. So one side of this square you can see comes out to be 2 times y, and another comes out to be 2 times x. Now they have given the side as 4. So twice of x is equal to 4, and also 2y is equal to 4. So you can see the value of x and y both comes out to be 2. If I want to find mod of z, it is nothing but root of x square plus y square, or nothing but root of 4 plus 4, that is nothing but 2 root. Hence option C becomes the correct answer. So very simple to do. If you are able to connect these three ideas, which time and time again will become very important in complex numbers. Now this next 2020 question again explores the same connection between coordinate geometry and complex numbers. So if I take z as nothing but x plus iy, the real part of z is nothing but x. So this equation that is written is nothing but mod of x plus mod of y is equal to 4. Now you can, this graph you should already know, but let us say if you do not know how we are going to do. If I take both the x and y in first quadrant, then this will become x plus y is equal to 4. That would mean in first quadrant, if I try and draw the graph, this is how the graph looks like. Similarly, in the second quadrant, if I take, that means x is smaller than 0, y is greater than 0. This modulus for x will open with a negative sign, and this is how it will look like. And here, if I draw it now, in the second quadrant, this is the line that we get. Similarly, in the third quadrant, that is x and y are both negative, the line, this equation will become minus x minus y is equal to 4, and it will become a line like this. And in the fourth quadrant, when x is greater than 0, but y is smaller than 0, if I consider this, it will become x minus y is equal to 4. And if I interpret it, this is how it is going to look like. So if I draw all of these graphs on one graph, this is a square that looks like this. For this square, this point is 4, this is 4, this is minus 4, this is minus 4. So now the distance from origin is nothing but modulus. So what can be the possible values of modulus? So the maximum distance that is possible is this distance from here to here. And the minimum distance that is possible is this distance from here to here. Now this is the midpoint of this line. So it is bound to be 2, 2. So now you can see the maximum distance or the maximum value of modulus is nothing but 4. So it needs to be smaller than or equal to 4. And the minimum value of z, so it needs to be greater than or equal to root of 2 square plus 2 square. That is nothing but needs to be greater than or equal to 8. So you can see that only those values of modulus are valid that are between root 8 and 4, that is nothing but root 16. So you can see your A option, B option cannot be correct for this, because they are talking about this cannot be. So cannot be is something root 7. So this cannot be your answer. Now let us look into this next problem type, that is based on algebraic form. Now complex number can be expressed into 3 different forms. The first one is algebraic form, where we can write z is nothing but x plus iy. We can also express this on the eigen plane as x comma y, which is equivalent to x comma y on coordinate plane, and x cap plus y j cap in vectors. So we are going to use this idea to solve problems. Now this problem was asked in 2019, and you can see that they are asking us to find the value of modulus of z. Now these kind of questions are based on equations that can be solved using putting z equal to x plus iy. Now there can be multiple ways. I am using the method that according to me is one of the best methods of solving all equation based questions, right? So here if you put the value of z is nothing but x plus iy, your mod of z can be substituted as root of x square plus y square, and mod of z is always real. So this is going to help us in solving the problem. So root of x square plus y square plus x plus iy is equal to 3 plus I. You can see that the real part on this side is this much. So root of x square plus y square plus x would be equal to 3 and y will be equal to 1. So once you have got this value, you can put this value of y in first equation. So this becomes root of x square plus 1 is equal to 3 minus x. Let us square both the sides. If I do so, it becomes x square plus 1 is equal to x minus 3 whole square, or x square minus 6x plus 9. And if I simplify this, what I'm getting is minus 6x plus 9 is equal to 1, or 6x would be equal to 8. That implies x is going to be 4 by 3. And once I have got this value as x is 4 by 3, y we already knew was equal to 1, I can get the value of modulus by substituting this value. So this becomes 4 by 3 whole square plus 1 square. That would be equal to root of 16 by 9 plus 1. That will become 5 by 3. So you can see our B option becomes correct. Now let us look into this next question that came into 2020. Again, what we will do here is put z is equal to x plus iy. And it is again a equation based question. So if I do so, x plus iy whole square would be equal to I times root of x square plus y square whole square. If I simplify, it is x square minus y square plus 2x xyi. Now we have done this multiple times, so I hope this you should remember. I into x square plus y square. Now compare real part with real part. So x square minus y square become equal to 0, and 2xy come out to be equal to x square plus y square. Now from here we can get two values. One is y is equal to x, or we can get y is equal to minus x. Corresponding to this, if I satisfy, this is my case 1. If I satisfy in this equation, then this becomes 2 times x square is equal to x square plus x square. And you can see that it is satisfying it. So twice of x square will be equal to twice of y square. And this is satisfying. Wherein if I take this, it becomes minus 2x square is equal to x square plus x square. It does not satisfy. So from here we can say that y is equal to x is our answer. That is option A. Now let us look into another question that was asked in 2022. Now you can see that it is almost same question, just that the summation concept they have added one more layer into it. So if I put it here, then x plus iy whole square plus x minus iy will be equal to 0. If I simplify, x square minus y square plus 2xyi plus x minus iy will be equal to 0. If I look into my real part and imaginary part, it becomes x square minus y square plus x equal to 0. This is my first equation, and simultaneously twice of xy minus y should also be equal to 0. So now you can see that the second one is more simpler to solve. So from this we will get our two cases. The first one is y equal to 0, or we can have nothing but twice of x minus 1 equal to 0, or x is nothing but equal to 1 by 2. Now consider these two separate cases, and in each of these cases let us try and get the value of the first one. If I put y equal to 0, this is my case 1. You can see that corresponding to y equal to 0, x square plus x will be equal to 0. And we are getting two values of x equal to 0 and x equal to minus 1. Fine. Now once we have done that, this is my case 1. Corresponding to case 2, that is nothing but y x is equal to 1 by 2. If I put it in this equation, it will become 1 by 4 minus y square plus 1 by 2 equal to 0. So y square is equal to 3 by 4, or y is equal to correspondingly plus minus root 3 by 2. So now let us see how many answers that we got. So the first case was when we got x equal to 0 and y is equal to 0. Corresponding to this, the complex number would be 0. Another case was if I put x equal to -1 and y is equal to 0. Corresponding to this, the complex number would be -1. Now these were from the first two cases. The second case is nothing but x is equal to -1/2 and y is equal to √3/2. Corresponding to this, the complex number is -1/2 plus I times √3/2. And the last one is x equal to -1/2 and y is equal to -√3/2. That is nothing but -1/2 minus I √3. Now let us look into the question once more. What the question is asking is, if you add all the real parts and imaginary parts, what is going to be the answer? So what they're saying is basically, take all the real parts. So if I look into all the real parts, that will come out to be 0, -1 by -1. And then in the second part, sorry, it was +1/2. Minor correction, sorry. So it becomes this. If I add 0, all the real parts, +1/2 +1/2, and then all the imaginary parts. If I add all the imaginary parts, it is nothing but √3/2 minus √3/2. You can see that this also adds up to 0. This also adds up to 0. So answer to this question is nothing but 0. The next question that we are going to do is based on JEE Mains 2023. Now, if I look into this question, what you can do is you can just put z is equal to x plus iy. If I do so, my left hand side becomes x minus iy, I into x plus iy whole square plus real part of z bar is nothing but x only. Now, if I simplify a bit and compare real and imaginary part, what I will get is I into x square minus y square plus 2xyi plus x. So if I simplify one more step, the imaginary part is x square minus y square plus x, and the real part is minus 2xy. So if I compare the real part, I get my first equation. From here, if I simplify, I am getting two values, x is equal to 0 or y is equal to -1/2. If I look into another equation, it is x square minus y square plus x equal to -y. Now, corresponding to the first case, that is x equal to 0, let us see what are the values that we can get. So if I put x equal to 0 into this, what I get is minus y square equal to -y. Minus I can cancel out. So there are two values of y equal to 0 and y equal to 1. This is 1. Another case 2 that we can consider is y is equal to -1/2. If I put it here, it becomes x square minus 1/4 plus x plus 1/2. And if I bring it on the left hand side, it becomes x square plus x minus 3/4 equal to 0. And you can solve this to get the value of x. So -1 plus minus root of b square minus 4ac by 2a. So if I simplify, -1 plus minus, and this will become 2/2. So if I take plus sign, what I get is nothing but -1 plus 2/2, that is 1/2. And if I take the minus sign, it is -3/2. So corresponding to this, now let us write all the possible values of z that we are getting. So if I write all the possible values of z, the first value of z that we got was x equal to 0 and y equal to 0. So z becomes 0. So corresponding to this, mod of z also becomes 0, and corresponding to this, mod of z whole square also becomes 0. The second case was the value of z comes out to be I or 0 plus I. Mod of z becomes 1 and mod of z ka whole square also becomes 1. In the next case, the z was nothing but 1/2 minus 1/2i. 1/2 minus 1/2i. And if I correspondingly calculate mod of z, it is nothing but √2/2. So mod of z ka whole square becomes nothing but 1/2. And the last value that we got for z was nothing but -3/2 minus 1/2i. Mod of z in this case comes out to be root of 9/4 plus 1/4, which will translate into mod of z is equal to 5/2. And now mod of z whole square. So now if I find the value of all the mod of z squares, if I add them, so it becomes 0 plus 1 plus 1/2 plus 5/2. If you add them, this comes out to be. Now let us look into this next question that was asked in JEE Mains 2023. In this question, what they're saying is, if I take my z as x plus iy, so the value of x they have already given is 3. So this is what is given in the question. They have given a complex number, that is z minus z bar plus zz bar divided by 2 minus 3z plus 5z bar. And in this question, what they're saying is the real part of this, whatever it comes, the range is alpha comma beta. Then find the value of the answer. So if you look into this question, there are 3 parts. First is, we need to figure out the real part of this new complex number. Let us say z1 they have given to us. Second, you need to find the range of z1. And in the third part, you get to the answer. So there are 3 steps in solving this question. So let us do all the steps one by one. Now this real part we have already figured out using expressing into the standard form of a plus iv. So it's exactly that we are going to do. So if I put z is nothing but 3 plus iy, and z bar will become 3 minus iy. Zz bar will become mod of z whole square, so 9 plus y square. And in the denominator, what I can write is nothing but 2 minus 3 times 3 plus iy plus 5 times z bar, that is 3 minus iy. If I simplify this, the numerator would become nothing but 9 plus y square plus 2iy, and denominator, if you simplify, what you get is 8 minus 8iy. Once you have this, and it is very simple, because now if I look into my numerator, it is 9 plus y square plus 2iy, and denominator I can take the 8 common and it becomes 1 minus iy. So in order to get the real part, I will multiply by 1 plus iy in numerator and denominator and simplify. If I do this, what I get in the numerator in the real part is 9 plus y square, and then what I will get as the imaginary part, and the other part would be when this and this gets multiplied, so that would be minus 2y square. Next part would be minus 1 into some imaginary part. We do not need to calculate it because it is not relevant to the question that is asked. And denominator, what we get is 8 times 1 plus y square. So now the question is plain and simple, that you find the range of this part. So we have already done the state or the first step of the question. Now let us move towards the next part of the question. So if I take this as real part, so 9 plus y square minus 2y square can be written as nothing but 9 minus y square by 8 times 1 plus y square. What I need to do is I need to find the range of this function. And in order to find range, there are multiple techniques that you can use. In fact, there is a clear-cut technique in quadratic equation in order to find this range. If you have not gone to the quadratic video, you can go and refer back to that video. But the logic is very simple in this case. What we are going to do is, in order to find this answer, we are going to reduce down. Now this technique, what I am telling you, we learn in function. So this is our part 2 of the question. Part 1 of the question we have already done. In order to get this answer, first let us simplify this. So if I simplify, this can be written as 10 minus 1 plus y square by 1 plus y square into 8 in the denominator. And this is nothing but a very simple expression that would become 10 1 by 8 times 10 by 1 plus y square minus 1. Now why is this relevant and important? Because now what we are going to do is we are going to break it down. So in order to get the range of this function, let us find the range of this function, 10 by 1 plus y square minus 1. And in order to get this, let us find the range of 10 upon 1 plus y square. In order to get the answer of this, let us find the range of 1 upon 1 plus y square. In order to get the answer of this, let us find the answer of 1 plus y square. And for this, what we require is y square. Now y square, you know, and is greater than or equal to 0. So if I add 1, it will be greater than or equal to 1. That is 1 to infinity. If I take reciprocal, 1 by infinity becomes 0. 1 by 1 becomes 1. If I multiply by 10, this becomes 0 to 10. If you subtract minus 1 to 9. And now if I divide by 8, so the answer of the question, or the part that is relevant to us, comes out to be nothing but minus 1 by 8 to 9 by 8. This is what is relevant. And why is this relevant? Now this is relevant because from here we can get the value of alpha and beta. Now if you look into the question, your alpha will come out to be minus 1 by 8 and your beta will come out to be 9 by 8. If you put in the expression that is given to us, that is 24 times beta minus alpha, what you get is 30. So your answer becomes nothing but D option. Now, if I look into this next 2023 question, it has 3 parts in the question. The first part talks about solving an equation. Now, once the solving an equation part comes out into picture, it is obvious to put z is x plus iy. Here they have given the value, so we will put alpha plus I beta. So this is the first part of the question, to solve this equation and find the value of alpha beta. And the second part says that you form a quadratic equation which has roots alpha plus beta and alpha beta. You need to be very careful, otherwise the answer can go wrong very soon. So let us start with the first part. So if I put this value alpha plus I beta plus 2 ka mod is equal to alpha plus I beta plus 4 plus 4i. Now if I take the real and imaginary parts together, the left hand side becomes alpha plus 2 whole square plus beta square, and right hand side becomes alpha plus 4 plus beta plus 4 times I. Now if you carefully observe and compare the parts, real and imaginary parts on both the sides, the value of beta plus 4 is 0. That implies beta comes out to be minus 4. So the first important thing we have already figured out. For finding alpha, we need to compare the real part, and that is nothing but alpha plus 2 whole square, and beta, if I put it here, will become 16, will be equal to alpha plus 4. If I square both the sides, it becomes alpha plus 2 whole square plus 16 is equal to alpha plus 4 whole square. So this becomes alpha square plus 4 alpha plus 4 plus 16. This is alpha square plus 8 alpha plus 16. So 16 cancels out. Alpha square will also get cancelled out. And you can see that 4 alpha will be equal to 4 alpha comes out to be 1. So you can see that by finding alpha is equal to 1 and beta is equal to minus 4, we have done with the first part. Now the second part, usually in JEE mains question, they will combine two different problem types from two different chapters. So the second part of the question comes from quadratic equation, which talks about formation of quadratic equation. So we have a formula there for forming quadratic equation, and then formula goes like this: x square minus sum of roots into x plus product of roots equal to 0. So for this we'll have to find sum and product of roots. Now you can see that the first root is alpha plus beta. So if I add alpha plus beta, I will get my first root. So my first root comes out to be nothing but minus 3. And for finding another root, alpha into beta, if I do, it comes out to be nothing but minus 4. Now I have figured out my roots, so I will have to find their sum. So if I find my sum, it is nothing but minus 7. And if I find the product, it is nothing but 12. Now, in order to form the quadratic equation, x square minus sum of roots into x plus product of roots equal to 0. So if I simplify this, you can see your D option will match. Now this next question is quite simple question. What they are saying is they have given a complex number and they are saying the real part is equal to a. In the second one, the real part is equal to b. You can see that what they have done is they have interchanged the value of a and b, and also it is given that a and b are real number and a is not equal to b. Having given these three conditions, let us write the real part of az square plus bz. So if I write z square becomes x square minus y square plus 2xyi. Now we have done this quite some time. And b into x plus iy is equal to a. So if I compare the real part, what I get is a times x square minus y square plus bx is equal to a. And all I need to do is interchange the values of a and b, and that is what has been done in the second part. So becomes b times x square minus y square plus ax is equal to b. Now what we can do is we can subtract these two equations. Why are we doing so? You will understand in a minute. So if I subtract this, it becomes a minus b into x square minus y square plus b minus a into x is equal to a minus b. Since a is not equal to b, I can cancel a minus b from both the sides. And if I do so, it becomes x square minus y square minus x is equal to 1. And you can see that if you simplify a little bit, you will see that there are multiple values. In fact, infinite values that can be substituted in this equation. And hence the answer becomes infinite. Now let us look into this next question of 2023. This question does nothing but plays on your confidence. So if you write what they are asking in the question, so let us say that a is also a complex number. So let us write this as a1 plus iota a2. Once you have done that, and let us also write z as nothing but x1 x plus iy. So if I do that, what you will observe here is, let us write the real part of a plus z bar. So a plus z bar would be nothing but a1 plus I a2 plus x minus iy. So you can see that the real part of a plus z bar is nothing but a1 plus x. Similarly, if I write nothing but a bar plus z, it is nothing but a1 minus I a2 plus x plus iy. And if I find the imaginary part of nothing but a bar plus z, it is nothing but, you can see from here, can be written as y minus a2. or minus a2 plus y. Now for the set A, the condition that they have given is whatever we are writing in the first part, that is a1 plus x, needs to be greater than y minus a2. So you can see that from here a1 plus a2 needs to be greater than y minus x. In the B part also they have given the same conditions. The sign has been interchanged. So a1 plus x needs to be smaller than y minus a2. So a1 plus a2 is smaller than y minus x. What they're saying is they have given two more conditions to us, statements to us. What they're saying is real part of a and imaginary part of a both are greater than 0. So if real part of a and imaginary part of a, that is a1. So in the statement 1, what they're saying is a1 and a2 both are greater than 0 because they have put a comma sign between them. If both are positive, in that would only mean from a set that y minus x is smaller than 0. Similarly, if I look into my statement 2, what they're saying is that a1 and a2 are both negative. If a1 and a2 are both negative, then a1 plus a2 will also be smaller than 0. So if it is negative number, then what we can say is y minus x can be greater than 0. So y is greater than x. Now this is also a region. This is the region above the line that I earlier drew. This statement is also false and hence option A becomes correct. Now this question that came in 2023 is extremely easy question. In this, if I assume my z1 is nothing but x1 plus I by 1 and z2 is nothing but x2 plus I by 2, and if I multiply z1 z2, what you are going to get is x1 x2 minus y1 by 2 plus I times x1 by 2 plus x2 by 1. I guess this is very familiar thing that we all know. Now what they're saying is the real part is equal to 0. That means this part will be equal to 0. So x1 x2 will be equal to y1 by 2. And in the next condition, what they're saying is the z1 plus z2 real part, that will be x1 plus x2. This is also 0. This is my next condition. So if you check out this condition from here, x1 and x2 are going to have opposite signs. So x1 is equal to minus of x2. Once you observe that, if x2 is positive, x1 will become negative, so on and so forth. Now, if I put x1 and x2 here in form of x1 only, it becomes nothing but. So here if I substitute the value of x1 in the first expression, it becomes minus of x2 square is equal to y1 y2. That means y1 into y2 is smaller than 0. And that would mean y1 and y2 is opposite signs. Now if you look into option A, they are saying they have same signs. Option D, same sign. But if you look into option B and C, what they talk about is they have opposite signs. Hence option B and C become the correct answer. Now let us look into this another question that came in 2023. In this question, if you put in place of z nothing but x plus iy, this question becomes a very simple question. Why? Because the left hand side will become x minus iy. Z square we have found it multiple times, x square minus y square plus 2xyi. Now if you compare the real and imaginary part, you can see that it can be written as minus 2xy plus I times x square minus y square. So if you compare real part, x is equal to minus 2xy. If I solve it, there are two solutions that we are getting, x equal to 0 or y is equal to nothing but minus 1 by 2. If I compare my imaginary part, what I am getting is minus y is equal to x square minus y square. So if I take x equal to 0 as my first case, what are the answers that I am getting? So minus y will be equal to minus y square. Correspondingly, either you will get y is equal to 0 or y is equal to 1. Now, if I take another value, that is y is equal to minus 1 by 2 and simplify, let us see what we get. If I put it, the left hand side becomes 1 by 2, x square minus 1 by 4. X square is equal to 3 by 4 or x is equal to plus minus root 3 by 2. Now let us look into the answers that we have got. One answer that we have got is nothing but I. Another one is 0. Then there is plus root 3 by 2 minus I by 2. And then there is minus root 3 by 2 minus I by 2. Now the question very clearly says that the vertices are non-real roots. That means we need to neglect the 0 and consider the other roots. Now here comes a very interesting part that you can use in most of the questions involving complex numbers and geometries. You can convert this question into a question of coordinate geometry. So what we could do here is basically corresponding to I, a point on coordinate plane will be nothing but 0, 1. Corresponding to this second point, a point can be root 3 by 2, minus 1 by 2. Corresponding to last one, the answer is nothing but minus root 3 by 2 minus 1 by 2. And now, if since we know these three roots, we have a formula for finding the area of a triangle when three roots are known. That formula goes like this: 1 by 2 times mod of x1 y1 1, x2 y2 1, x3 y3 1. So all we need to do is we need to substitute these values. So if I do so, it becomes 1 by 2 times determinant of 0 1 1 root 3 by 2 minus 1 by 2 1 and minus root 3 by 2 minus 1 by 2 1. And if we simplify this, the answer that we get is nothing but 3 root 3 by 4. And because we also need to consider modulus sign of this. You can see our A option matches. Now in this question, you might have seen a very unique thing that we did. We converted a question of complex number into coordinate geometry and we solved it. So this linkage between complex number, coordinate geometry and vectors is very important that we are going to time and time again use in questions involving geometry. Now let us go into type 7 problem type, that is trigonometric and exponential form based questions. Now for a complex number, as a layman we should know that there are three forms. First one is algebraic form, or z is equal to x plus I1. Another one is z is equal to r times cos theta plus I sin theta. This is nothing but the polar or trigonometric form. And the third one is r e raised to the power I theta. Here respectively, the value of r is nothing but modulus of z and the value of theta is nothing but argument of z. A very important idea based on this logic is nothing but de Moivre's theorem, and this theorem is very simple. So if I write e raised to the power I theta, it will be nothing but cos theta plus I sin theta. So if I write e raised to the power I n theta, on the right hand side we can write this as cos theta plus I sin theta raised to the power n. But if I just replace theta with n theta in the first one, I will get my left hand side, that is cos raised to the power n theta plus I sin n theta. Now this theorem that I have written here is known as de Moivre's theorem. Generally while applying this theorem, we will apply this theorem, but more generally we will apply the exponential form from where the theorem comes. So let us jump into the problems based on this idea. Now let us start our discussion with first problem that came in 2020. Now this is a very simple problem. Now my technique is to use less properties and more these forms and directly get answers from there. So let us see how this technique works out. So what we can do is this part that is written in the numerator, we can convert this into its exponential form. So it will be r here comes out to be 2, and the argument, since it is in the second quadrant, comes out to be 2 pi by 3. The second one, that is denominator 1 minus I, if you find r, it is root 2, and argument in this case is nothing but minus pi by 4. If I divide this, what will happen is 2 e raised to the power I 2 pi by 3 divided by root 2 e raised to the power minus I pi by 4. This will get divided, and then there is 30 in the power. So it becomes root 2 into e raised to the power 2 pi by 3 plus pi by 4 into 30, and this 30 will also come in the power of root 2. Now in the next step we can directly multiply 30 inside. So if I do so, what I get is nothing but 10 pi, and here it will become 15 pi by 2. Now interestingly, if I further simplify it, this can be written as nothing but 16 pi, 6 we have borrowed from this 15 pi by 2 plus 3 pi by 2 into a. Now if I split into two parts, and this you should generally know that e raised to the power I 2 pi or any multiple of 2 pi will be equal to 1. This is very simple. You can do it from polar form and can also observe. So you can see that this part, when you will write separately, I will write and show as well e raised to the power I into 16 pi and e raised to the power I 3 pi by 2. Now this part that we have written here will become nothing but 1. And the second part will become nothing but minus I. So your answer becomes minus I 2 raised to the power 15, and that is nothing but option. Now let us look into next question that also came on the same idea, and here there is a minor simplification that we are going to do, and I will also tell you a shortcut that works on all such questions. So what you can do is, see, what we know is this formula of 1 plus cos theta, that is nothing but 2 cos square theta by 2, and 1 minus cos theta, that is nothing but 2 sin square theta by 2. Problem here is that instead of that we have 1 plus sin theta. So what we are going to do is we are going to convert sin theta into cos theta by applying cos theta is nothing but sin of pi by 2 minus theta. If I use this logic, if I have sin 2 pi by 9, I can write this as cos of pi by 2 minus 2 pi by 9, and which in turn can be written as cos of, if I simplify whatever is inside, it will become cos of 5 pi by 18. Once you have done that, interestingly, we can rewrite this statement into the question into 1 plus cos 5 pi by 18 plus I times sine pi by 18, 5 pi by 18. And in denominator 1 plus cos of 5 pi by 18 minus I sine 5 pi by 18. And now you can observe what I will do here. And this is something very general that we will use multiple times in multiple questions. So now 1 plus cos theta can be written as 2 cos square theta by 2. So this becomes 5 pi by 36. Here also sine 2 theta can be written as 2 sine theta by 2. That is 5 pi by 36 into cos of 5 pi by 36. In the denominator, same thing, 2 cos square 5 pi by 36 minus I times 2 sine 5 pi by 36 and 2 cos 5 pi by 36. And you can see now that on this power we have 3. What will happen after this? Now you can see that this part, that is 2, get cancelled out. Also you can see that this cos terms will also get cancelled out. So what we are getting after this simplification in the numerator is nothing but cos of 5 pi by 36 plus I sine 5 pi by 36, and in denominator what we are getting is cos 5 pi by 36 minus I sine 5 pi by 36 raised to the power 3. Now what you can do is the numerator part we can write as I raised to the power 5 pi by 36. Denominator becomes e raised to the power minus I 5 pi by 36 raised to the power 3. And if you simplify it is e raised to the power I 5 pi by 18 into raised to the power 3. And if you simplify it becomes e raised to the power I 5 pi by 6. And if you simplify this, it becomes our option B, that is minus root 3 by 2 plus I by 2. If you want, I can simplify it. So if I simplify this part, e raised to the power I pi by 6, you can see that it becomes cos 5 pi by 6 plus I sine 5 pi by 6. Put the value and get the answer. Now again in 2023, similar type of question has been asked. Again, you can write the numerator into exponential form as root 2 e raised to the power I times 3 pi by 4. The denominator can be written as e raised to the power I pi by 3. And if you simplify it is root 2 e raised to the power I 3 pi by 4 minus pi by 3. That is nothing but root 2 e raised to the power I 5 pi by 12. And if you see directly B option matches. So this question can be done in under 30 seconds. Now an extremely simple question was in 2019. And this question you can do just by observing the question. No need to even lift your pen. If you look into this question, they are adding a complex number with its conjugate. So what we are adding is z plus z bar. If you add z plus z bar, the answer is going to be 2 real part of z. So I'm assuming this to be, let us say z1, in order to avoid any kind of confusion. So what you can see is, what you should get is a real value because you're adding a number with its conjugate. So by default, the imaginary part of z that is given in the question needs to be 0. Hence option B becomes correct. Now this question that was asked in 2013 is based on the similar logic of 1 plus cos theta that we saw earlier. So what we are saying is it has a unit modulus and argument is theta. So if I want to write this in polar form, it is nothing but cos theta plus I sin theta. So this is what we know about the complex number set. If I put it here in this 1 plus z by 1 plus z bar, it is going to become 1 plus cos theta plus I sin theta and 1 plus cos theta minus I sin theta. And if you simplify, what you get is 2 cos square theta by 2 plus I times 2 sin theta by 2 cos theta by 2 divided by 2 cos square theta by 2 minus 2 I sin theta by 2 cos theta by 2. So if you simplify this, 2 and cos theta by 2 will get cancelled out. And if you simplify this part, it becomes extremely simple. In the numerator, it is cos theta by 2 plus I times sin theta by 2. And in denominator, you have the same expression, but with a negative sign. So numerator part can be written as e raised to the power I theta by 2. Denominator will become e raised to the power minus I theta by 2. So answer becomes e raised to the power I theta. So your argument here is nothing but theta. And that is option C. And this logic of 1 plus cos theta, 1 minus cos theta, and sin theta using those half angle formulas in trigonometry is very important, will be used multiple times. Again, the 2023 questions based on similar concept. So what we can do is this 1 minus root 3 I. If I write in terms of exponential form, it is 2 times e raised to the power I minus pi by 3. So if I raise it to the power of 200, it becomes a 2 raised to the power 200 and e raised to the power I minus of 200 pi by 3. And this is equal to nothing but 2 raised to the power 199 p plus iq. Now your job is very simple. Simplify it, find the value of pq, and then do whatever they're asking you to do in the question. So if you simplify it, this becomes 2 into e raised to the power minus I times. Now if this you simplify, it becomes 66 pi plus 2 pi by 3. And I have already told you that e raised to the power 2 pi will have no significance on your question. So this becomes e raised to the power minus I into 66 pi into e raised to the power minus I 2 pi by 3 is equal to p plus iq. Now this part will become 1 because e raised to the power 2n pi form is there. So if we take the circle, it will come to the same part 1. And if I simplify, what I get ultimately is cos of minus 2 pi by 3 plus I times sine of minus 2 pi by 3 equal to p plus iq. And if I further simplify, this becomes minus 1 by 2 minus I root 3 by 2 is equal to p plus iq. If I simplify it further, the value of p comes out to be minus 1 and the value of q comes out to be minus root 3. Now let us go back to the question. What they're saying is they need to make a quadratic equation with these two roots. So if I find these two roots, the first one is nothing but p plus q square. So if I add p, that is minus 1, plus q, that is minus root 3, and q square, that is 3, it becomes 2 minus root 3. And if I do it for the other one, it is p minus q plus q square. So if I put it minus 1 plus root 3 plus 3, that is 2 plus root 3. If you use these both of these roots, then the equation formation will be x square minus sum of roots into x plus product of roots equal to 0. If I do sum, it becomes x square minus 4x, and if I do product, it becomes 1 equal to 0. Hence our option B comes out to be correct. Now this very beautiful question came in 2021 and is amalgamation of few ideas. Let us see those ideas. So first, in order to understand what this is written, let us put z is equal to x plus iy. And if I do so, what I get from this is nothing but first part, or w, will become nothing but x square plus y square minus 2 times x plus iy plus 2. And if I simplify this, it becomes x square plus y square minus 2x plus 2. This is the real part. And plus minus 2 iy. This is nothing but the imaginary. Now, this is the first part. They have also given one more condition that z also belongs to this set. So let us also simplify that part. So z plus I ka mod is equal to z minus 3i mod. So if I simplify this, it is x square plus y plus 1 whole square. The second one is x square plus y minus 3 whole square. And if you simplify this part, this becomes y square plus 2x plus 1. X square will get cancelled out. Y square minus 6x plus 9. So again, y square will also get cancelled out. What we are getting is 8y is equal to 8 or y is equal to 1. Now you can see that the value of y is 1 here. So if I simplify my w becomes x square plus 1 minus 2x plus 2 and minus 2i. Now again, if I simplify this part, it becomes x square plus 2x plus 3 plus 2y. Why this is interesting? Because what we are saying is the real part of w becomes minimum. So now again, let us look into this. So if we have x square plus 2x plus 3, what can be its minimum value? So let us make the perfect square. So x plus 1 whole square plus 2. So you can see that this will become minimum when x becomes minus 1. So minimum value becomes nothing but 2. So let us find w minimum. It is nothing but 2 plus 2i. Now this is very interesting. What they're saying is 2 plus 2i. And what they're saying is what should be, and if I simplify this into exponential form, it will become 2 root 2 e raised to the power I pi by 4. Why are we writing this? Because now they are saying that this is w minimum raised to the power n. That means 2 root 2 e raised to the power I pi by 4 raised to the power n. This should become nothing but real. This can, what minimum value n can take? So it is obvious, if this n becomes equal to 4, answer would be real. So answer becomes 4. The type 8 problem type is nothing but questions based on cube root of unity. Now let us first look into the basic theory of cube roots of unity. So if I take x cube nothing but equal to 1, then it can be factorized into x cube minus 1 equal to 0. That would imply x minus 1 into x square plus x plus 1 equal to 0. So if I put x minus 1 equal to 0, I get the first cube root of unity, that is 1. And if I put the other one, that is x square plus x plus 1 equal to 0, I get two roots out of it. X is equal to minus 1 plus minus root of 3i by 2. So if I take plus sign, I get omega. So my omega is equal to -1 plus root 3i by 2. And if you square it, you get the another one, that is -1 minus root 3i by 2. There are three cube roots of unit, I, omega and omega square, like we have written here. Omega is this, and if we write in Euler's form or exponential form, it is e raised to the power I 2 pi by 3. Omega square is nothing but -1 by 2 minus I root 3 by 2. And if I write this in exponential form, it is I raised to the power 4 pi by 3 or -2 pi by 3, same thing. If I talk about properties of cube root, the first property is if I have 1 omega and omega square, the sum of them is equal to 0. So 1 plus omega square equal to 0. You can put and check. Also, if I multiply all of them, that is omega cube, it comes out to 1. Again, you can put and check. So these are two basic properties that will be used like 90% of the times. But there is one more idea. If I raise this 1 raised to the power r, omega raised to the power r, and omega square also raised to the power r, the value of this expression will depend on the value of r. If r is not a multiple of 3, then in that scenario, the answer is equal to 0. But if it is a multiple of 3, then the answer of this expression becomes equal to 3. You can put the values and check. If I plot them on an Argand plane, this is how they look like. So this is my 1. Then I 2 pi by 3 would be some, omega would be somewhere here and then here. If I join all of them, this is how they look like. You can see that this angle from here to here is nothing but 2 pi by 3. And this angle again from here to here is 2 pi by 3. And this angle again from here to here is nothing but 2 pi by 3. So interesting part is that all of them lie on a unit circle. So if I draw a circle circumscribing this triangle, it is nothing but a unit circle. The radius of this is equal to 1. And that is because if you take the modulus value of all of these complex number, it comes out to be 1. So the distance from origin is equal to 1. Hence they lie on a unit circle. Another interesting part is since this angle is equally divided, this triangle that we are talking about, this is an equilateral triangle. And if you want to find the area, it is not very difficult. You can do that as well. It is half of base into height. Now, once you have done this, this is the geometrical part analysis of this. One more idea that comes handy while solving problem is, instead of 1, if I take cube roots of -1, so this will become x cube plus 1 equal to 0, or x plus 1 into x square minus x plus 1 equal to 0. So you can see that one value comes out to be -1. And another two values, if you find, come out to be minus omega and minus omega square. Now this is a very important result, especially if you have been given this quadratic equation. They're talking about roots of this equation. You can consider this as minus omega and omega square. Now once we have looked into these basic results, now let us see what kind of questions JEE has asked on this idea. Now let us look into this first question that came in 2004. And in this question, what you can see that all we have to use is two property. One is 1 plus omega square is equal to 0. So if they're asking 1 plus omega square, the value of 1 plus omega square is nothing but minus omega. And if I look into this second part, 1 plus omega raised to the power 4 they have written. Omega raised to the power 4 can be written as 1 plus omega because omega cube is equal to 1. So whatever power they are raising to the power of omega, we need to divide it by 3. Whatever remainder is there, we will raise it to the power of omega. Like 4, if you divide by 3, the remainder is 1. So it becomes omega raised to the power 1. Now from the same identity, the value of 1 plus omega will come out to be minus omega square. Now if you take these two values and put it in the question, the left side becomes minus of omega raised to the power n. Right hand side becomes minus of omega square raised to the power n. So what we are getting ultimately is omega raised to the power n is equal to omega raised to the power 2n, or omega raised to the power n is equal to 1. This can only happen when n is a multiple of 3 and the lowest value can be 3. Now let us see another problem that came in 2021. What they are saying is the sum of the 1/62nd power of the roots of this equation. So let us find first the roots of this equation. So we can regroup it as x cube minus 1 and minus 2x into x minus 1 equal to 0. So you can see that from here and here I can take x minus 1 common. What is remaining is x square plus x plus 1 minus 2x equal to 0. So x minus 1 into x square minus x plus 1 equal to 0. Now from here we'll get one of the roots as x equal to 1. From here we have already seen this when I taught you the basic theory. The answer is minus omega and minus omega square. This is very handy. So what they're asking in the question is very simple. Raise all of them to the power of 162 and add them up. So minus omega raised to the power 162 and plus minus omega square raised to the power 162. If you do this first one, it comes out to be 1. Now you can see that omega raised to the power, you look into this quantity, it is a multiple of 3. So what will happen is basically this will become 1. This will also become 1 and the answer becomes 3. Now this next question was asked in 2020. The question is very simple. If you identify one fact, and what is that one fact is this value of alpha that they're giving in this question is nothing but omega. If you identify this, your life becomes very easy, because then you can directly put it here as 2 plus omega raised to the power 4 is equal to a plus b omega. And your life becomes very easy, because now you can use the properties of omega. So if I simplify this, this is nothing but 1 plus omega raised to the power 4 is equal to a plus b omega. 1 plus omega can be written as minus omega square raised to the power 4 is equal to a plus b omega. Now I am taking one power. So what we can do is, we can write this as 1 minus omega square whole square is equal to a plus b omega. And now if I simplify this, this is 1 plus omega raised to the power 4 minus 2 omega square raised to the power 2 is equal to a plus b omega. And omega raised to the power 4 is nothing but omega only. So this is 1 plus omega minus 2 omega square raised to the power 2 is equal to a plus b omega. 1 plus omega can again be written as minus omega square. So again, if you simplify this, what you get is nothing but minus 3 omega square raised to the power 2 will be equal to a plus b omega. This, if you simplify, is nothing but 9 omega raised to the power 4 is equal to a plus b omega. And omega raised to the power 4 will again become omega only. So now if you compare both the sides, what you are getting, the value of a you are getting is 0 and the value of b you are getting is 9. So if I want to find the value of a plus b, it will come out to be 9 only. Hence my option B becomes correct. You can see that 90% times we are using the two very basic ideas, that is 1 plus omega square is equal to 0 and omega cube is equal to 1. Sometimes we use this idea that x square minus x plus 1 equal to 0 will have two roots, minus omega and omega square. Now again, this question asked in 2022 appears to be a difficult question, but actually is a very simple question. If you identify this one thing, that is this equation. So the roots of this equation are nothing but omega and omega square. So I can take any one value and find the value of this expression. So for finding this expression, let us first go inside this. So what we have been given is z raised to the power n plus minus 1 raised to the power n by 1 by z raised to the power n whole square. So let us put in place of z omega. So this becomes omega raised to the power n plus minus 1 raised to the power n by omega raised to the power n whole square. And if you simplify, omega raised to the power 2n plus 1 by omega raised to the power 2n and then plus 2 minus 1 raised to the power n. And if I simplify this omega square, see, this is again very simple idea but important idea. If you multiply this by omega numerator denominator, it becomes omega by omega cube, that is equal to omega by 1 or omega. This is a simple and very powerful idea. So whenever we find 1 by omega square, you can directly replace it by omega. This is again a very small shortcut but very useful. So this becomes omega raised to the power 2n plus omega raised to the power n is equal to 2 into minus 1 raised to the power n. So we have simplified this enough. Now what we are going to do next is we are going to find the value of this summation and then take mod of it. Because there are two things. Mod is also there. Do not forget this mod. Sometimes you'll forget the mod and then you'll wonder why the answer is not coming. If I apply the summation, you can see that it will become summation of omega raised to the power 2n from n equal to 1 to 15. Then second becomes summation of omega raised to the power n is equal to 1 to 15. And the last part is 2 into summation of n is equal to 1 to 15 minus 1 raised to the power. So if you simplify, write this, it is nothing but omega square plus omega raised to the power 4 up till omega raised to the power 30. The second part becomes omega plus omega square plus omega cube, and again up till omega raised to the power 15. And the last part, if you write, will become 2 times minus 1 plus 1 minus 1 plus 1 and up till minus 1. Now if you closely observe this series that we have, this series omega plus omega square, you can see that in this, the first term, if I look into this one, the first one, if you closely observe the 3 terms, omega square, omega raised to the power 4, omega raised to the power 6. So this is omega square only, but this will become omega and this will become 1. So it is 1 plus omega square becomes 0. So the pair of 3 terms will become 0. So ultimately the first part will become 0 only. Why? Because omega square, omega raised to the power 4, omega raised to the power 6 becomes 0. Then omega raised to the power 8, 10 and 12 will again become 0. So like this 3 pairs are becoming 0. Similar thing is happening with this part also. So this also becomes 0. So no calculation you need to do. And this part also, if you take pairs of 2, it is becoming 0. So till 14 it will be 0. But last one, minus 1 will remain. So answer becomes nothing but minus 2. So it is very simple to calculate it. Now this is not the answer, we need to take modulus. Hence 2 is our answer. Now this 2019 question is again very simple question. Why? Because if you observe this x square plus x plus 1, you will be able to identify the root as omega and omega square. In order to find the value of z, since it is a single option correct question, you do not need to consider both the values. Take any one. I am taking omega. So if you write this z, it is nothing but 3 plus 6i omega raised to the power 81 and 3i omega raised to the power 93. Now this is also a multiple of 3. This is also a multiple of 3. So both of them will become 1. So this becomes 3 plus 6i minus 3i, or it is nothing but 3 plus 3i. If you look into this, the argument of this comes out to be pi by 4. Hence A option becomes correct. Again, a very simple question that came in 2020. In this question, they have given the value of alpha, and again, your job is very simple to identify that this is omega that is given to you. Now let us look into the question. If A they are talking is nothing but 1 plus omega, I am replacing alpha by omega. Summation of k is equal to 0 to 100 omega raised to the power 2k. If I simplify this, this becomes 1 plus omega. And if I write this, it is 1 plus omega square, and it will go up till omega raised to the power 200. So it will become 1 plus omega. And if I apply the sum of geometric progression, it comes out to be a into r raised to the power n minus 1 by omega square minus 1, because your value of r is nothing but omega square. This becomes 1 plus omega raised to the power 202 minus 1 by omega minus 1 and omega plus 1. Omega plus 1 gets cancelled out. If you simplify this, this is nothing but omega only. So omega minus 1 by omega minus 1 again gets cancelled out, comes out. So the value of A is nothing but 1. Now let us look into the value of B. If you look into the value of B, it is omega raised to the power 0, omega raised to the power 3. All the powers are multiple of 3. 300. You can see that all of them will become 1. And hence the answer becomes 101. Now one root is 1, another root is 101. So the product of root will become 101 only. And hence, if you look into this, option A will become correct. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.